Hello.
Hello.
Hi. Hi, my name is Gabriel. I'm from Data Scientist and we're full of pride and happiness. I will present you Gentrit Fazlija. He studied mathematics, philosophy, and data sciences. His focus is NLP, and he is now he was holding more than 50 workshops already to this different or specific topic. He told me that actually before there was anything like ChatGPT, he was already so interested in the language models. So this is somebody who's not riding on the wave. This is somebody who was creating the wave. So, Gentrit,
I
do
cannot
you
hear
hear
you
me?
right now.
Anybody hear me?
Yes, now
Oh
I can
man,
hear you again. Yeah.
sorry. Okay, so you were creating the wave, and you will hold the workshop or the webinar Transformer Architecture Introduction into Artificial Intelligence using ChatGPT. Gentrit, the floor is yours.
Thank you a lot, Gabriel. So for everybody, just that to do some expectation management. So what we will see in the following talk from my side is an introduction into the transformer architecture on a more intuitive level. So what I want to give you is like an idea of how to think with respect to what's going on in this architecture that has been founded a few years ago that actually now enables the current AI wave or AI revolution, how we would say that. Obviously, if you understand it a little bit better, so we will try to talk like 45 minutes and afterwards I'm going to go into questions. You will be able to uh, hopefully prompt a little bit better because you understand like, okay, how ChatGPT actually understands like my input, and you will be able to understand maybe also some mishaps that ChatGPT is taking. Yeah, therefore, that's expectation management. Let's go into it directly, I would say. And if you have any questions, obviously, always ask in chat. I'm here and happy to help. Okay, let's go. So, as every good mathematician, I would like to start with a definition. And just here, I will say it in the beginning that there is no real definition of artificial intelligence. There's just one definition that I go along with. But obviously, we can like be really philosophical and really strict with the different words. But let's just go into it. Artificial intelligence (AI) refers to machines that simulate human-like cognitive function, such as learning, understanding, and decision making. This includes problem solving, recognizing patterns, and understanding language and making decisions. Here on this first paragraph already, we have our first learning point, and that would be recognizing patterns. That is like the most important point in this whole paragraph. So when we talk about AI, we actually just try to understand that these models are trying to understand the patterns within the data set that we have. Now we are interested in the transformer, so more specifically like ChatGPT. So we are interested in written text. With respect to this written text, we have to understand that there is already like intrinsically some structures and some dynamics that we, like you and I, we can have an intuition about, but machines can learn these connections, and we have to leverage these connections. As also the architecture that we'll be introducing in this talk is also learning them. Um, let's continue with the definition. AI technologies encompass different approaches and techniques, including machine learning, neural network, deep learning, natural language processing, and more. I really like this paragraph because maybe you've already seen that starting in 2023, 22, and now also like 2024. But AI is just like a buzzword as so many others. But AI is actually there's actually a plethora of different things. So usually like you have like machine learning, deep learning, natural language processing, vision models, and so on and so on and so on. And given the specific use case and the specific problem that you are trying to solve, you actually also want to use different machine learning frameworks for that. It is important to emphasize that although AI systems can show impressive performance in certain domains, they generally do not have a general understanding or awareness, as it is the case with humans. This specific language or this specific sentence I actually put in just to be a little bit more vigilant with the way I'm using specific languages. I'm in a way anthropomorphizing like AI models, like I'm giving them a human-like attribute. For example, I sometimes say during my talk, like they think or they read or whatever they say, they speak, and so on and so on. Obviously, it's not like real they are thinking, like you and I are thinking, like we are human with consciousness. But I'm just trying to to say that I will use these words just to be on a similar ground bed, so that you and I can talk about this. And where was I? Indeed, or instead, there are usually specialized in very specific tasks. This is a very not old, but this is an older definition where everybody would have gone with it like 2 years ago. And this is also like the third or fourth learning part here of this definition already. 3 years ago, 2 years ago, everybody in this whole AI space, data science space, would have really said, okay, we have to understand what is your problem, and then we will find a solution encompassing or solving this problem. Now with these new models, these maybe you have seen like 2 days ago, where Llama 3.1 came out, and it's also like really good with respect to the evaluation. With all these new models that can do multiple tasks, now the whole definition is a little bit wishy-washy, is like a little bit washed up, where we actually see now that it can actually also do general tasks really well. Okay, what is ChatGPT? I hope everybody knows that here. I will just go into it. I was like thinking, okay, how can I explain actually ChatGPT so that it will motivate like the transformer architecture? And then I asked ChatGPT it myself. I said, like, as a part of a workshop, I would like to demonstrate the possibilities and capabilities and so on and so on. Just tell me what you can do. And then ChatGPT just said to me like, oh, I can do like some storytelling. I can give you some tutoring, education. We can like simulate a professional role and so on and so on. ChatGPT cannot just do that, but ChatGPT can even do more things. It can do a whole plethora of things. Like these are the things that it can do. For example, it can generate lists. It can rewrite statements. It can create poems. That's like a really funny thing. So if you have any like person that it's dear to your heart, you can just tell them like, okay, here, create like a poem, write a story, and so on and so on and so on. The learning regarding this slide is that look at the radius, look at the thickness of the different areas it can do something. So, for example, if you look into the thickness of generate, this tells us that with respect to the training data it was given, it has done more generating than creating poems. It has generated more lists than it has created poems. And this is another learning for you, that you have to think of, okay, actually ChatGPT can do almost everything, can it? No, it can do everything because it simulates to do everything. But with respect to one thing or another, it can do it with different amounts of accuracy or confidence or strictness and so on and so on. Therefore, also maybe you have seen that ChatGPT is at its current state really bad with citations. That's also like a thing because it has not learned a lot of citations, but this will with time probably also get better. Here we see also other stuff, other areas like summarize articles is also like fairly big of a training chunk and so on and so on. AI is just one thing. What I want to do now is to give you like a little bit of a broader sense and to understand where this architecture actually came from and what it is enabling. So ChatGPT is one thing. obviously. But we have also Midjourney. For somebody that doesn't know it, with Midjourney, you can create pretty pictures. You can create like this dog, portrait of a dog. You can create this stock character in front of a supermarket. You can create this UI of an application. You can create interior design. You can create this Pixarish like character during Halloween. So we have already seen, with respect to these two AI solutions, we have seen that one, you put in written text in, and written text is coming out. That's ChatGPT. You see with Midjourney, you put in written text in, and what's coming out is pictures coming out. Then a next solution or next product would be like 11 Labs. I've already tried it before the call. It didn't work. To like, you will not hear anything, but I would tell you just to go into YouTube and just write like 11 Labs demo, and then you will hear how crisp and perfect and human-like they actually talk. You can even hear like the breaths with respect to one sentence to another. So it's really like human-like. And what they do is you put in written text and it gives you out a language. So obviously you can also give it a language and then language comes out. But I'm just trying to give you like this framework that you have to think of. Another product, and that's the last product, that would be like HeyGen. What you do here, maybe somebody recognizes this fellow. This is MKBHD, American YouTuber. And what he, he's American, therefore he speaks English. And what happens here with HeyGen, with this product, is you put in a you put in a video of somebody talking in one language. Then there are happening multiple things. One is the language that he speaks will be transcribed using Whisper, like the Whisper model. This is like a transcription model. Then this transcription will then use ChatGPT 4 or some other ChatGPT version to translate it into Spanish. Then we have Spanish text. Then there is the Spanish text, and this Spanish text will then be using 11 Labs to create a Spanish voice, while it will be trying to also duplicate the voice of the speaker at the same time. And then in the last, now we have the Spanish voice. In the last step, HeyGen, what it does is it will use like an open source model where it will mimic the lip movement perfectly, where while it talks in Spanish, it will then try to adjust the lips appropriately. And this is what's happening in HeyGen. So multiple AI solutions in the backend. So what happens here is video in, video out. And now we can ask ourselves, like, where does this all come from so suddenly, actually? And this is on our way of understanding the architecture. We have to understand that actually everything here is just zeros and ones. So text, zero and ones, pictures, zero and ones, like RGB coordinates and just numbers. Video, zero and ones. Everything is zero and ones. And what we have done in this timeline, in the time that we are living in, what this architecture has enabled us is to connect all these different zero and ones. So there is one, let's call it an island of code. There is one island of text. There is one island of robotic. And all these different islands are now connected with each other, using or being enabled by this architecture, namely the transformer architecture that we will see in this workshop. So what have we seen up to this point? We have seen AI doesn't mean AI. It's actually very specifically with respect to the specific task that you have to use different AI or machine learning models. That's the first one. And what we have seen also is, second one would be, okay, so we have had pictures, we have had language, written and also spoken language with MP3 models, MP3 format, and so on and so on. So we have had this, we have had everything before 2020, 2021. We have had all of them. But what happened now is that there is something new in the block that actually enables to connect these. And not just with respect to different islands, but also with respect to one island itself. And that would be language, written language. And that's where we are now going into more deeply. Before that, though, I would love to actually show you one example that really like struck me when I saw it the first time, and that would be like the connection between a camera and a Wi-Fi signal. Let's say here in my room on the right corner here, I will have like a camera pointing into my room and also Wi-Fi signal and also receiver on one side that actually just like a bat gives like the signals in the room and then also sees like which signals in which frequency and which distance and so on come back. If we think about that, if you think about this setting and we have that constantly like looking into the room and the camera actually already being trained into creating a 3D mesh of a person, then we can see that we are able to create a 3D mesh, and the VLAN signals will only be encapsulated by the same framework as a bat does it. Now we are like, okay, these two models, these two frameworks have learned enough from each other. They have seen each other enough. So then we will just close the camera and we will only leave the Wi-Fi signals on. And then we will create a 3D mesh of people not using the camera anymore, but just the Wi-Fi signals. And that is actually the power that this new component, the new architecture does with respect to connecting now different islands that were never connected before. Okay, let's get into the scientific background. What we want to do now, it's a little bit more vigilantly and also more visually appealing with respect to what I try to say in artificial intelligence, the different domains. So first we have artificial intelligence, which is AI. This is like the buzzword. Then we have machine learning. This is like some smaller subset. Then again, we have deep learning, which is just a more complex way of machine learning. Then we have different areas which are intersecting with different areas of what I've already said. So that would be like natural language processing, which I'm really interested in and in going in, and also computer vision, with which some of my colleagues are really into. And where we find ChatGPT and also other multimodal models is here at an intersection between all of these different frameworks. But how is it trained? When we say about trains, we talk about first data. We have like different data. We have text data, we have pictures, we have speech data, we have structured data, we have signals, and so on and so on and so on. And we put that into the training, trying to train a language model, ChatGPT. And I really like to explain that training by an analogy which I also would explain to a child. And that would be like with puppets, where we say like, okay, we have like two puppets on this side and on this side. We say this is the human and this is the AI model, the speech model, whatever. Actually, the deep neural network, but whatever. And we say like, okay, what is 2 plus 2? And then the deep neural network or the model, whatever, says like 7. And we say like, no, it's wrong. What's 2 plus 2? It's 6. No, it's wrong. What's 2 plus 2? 5. Wrong. What's 2 plus 2? 4. Okay, perfect. And this thing, what I just said, does not happen like as slow as I have just said it, even though I try to speak as fast as possible. But this happens literally millions of times in a minute. Like it happens so fast, and it just happens even faster and faster and faster. In a few minutes, I will go into like GPUs and will give you like an intuition of how fast it actually happens. Then what happens when we have trained this? Let's have this puppets as a mental framework. We do then adaptation afterwards. We say like, okay, we have now tasks, and we can either question answer, we can sentiment analysis, information extraction, image caption, object recognition, or instruction following. And we like give it like specific tasks. And actually here, really interesting, just like as a small caveat of information, the tasks were actually before all of this happened, before this AI revolution happened, because NLP, so natural language processing, actually was not around for the past like 3 years or so, but it was actually almost it was an area which is almost 100 years old. So actually it's a really, really old area, where previously with older models, we had to specifically say, okay, now we have this sentence and we want you to do sentiment analysis on this sentence. So we had to really be specific with the task. But now everything is, as I already said, like a little bit washed up, because it just now better. The models are bigger and they are able to understand it better, what they have actually actually what they have to do. Um, this is like a mental picture of understanding which different models we actually have. So as already said, like we have different frameworks, we have different models. Here, probably the most interesting for us right now are these here. So that would be like the Llama models, BART, or now they have also like Gemini, GPT. Uh, yeah, this one here, and Claude is really big. Claude is also really big and will get bigger with time for sure. Yeah. So let's now go one step deeper and try to build a language model. Okay, we will start with the Oxford Dictionary. The first words are like al, and the last words I cannot even pronounce this. Zitsivar, yeah, whatever. And there are like 273 approximately words in Oxford Dictionary, and we now give them like an index. We have all these words one after another, and we want to create the word. We want to create the sentence. How are you doing? We start with how. When we have the word how, then we have some kind of a probability distribution. We know, okay, we start with the word how, and what would be the next word given all the different words that we have already seen previously, all the different texts that we have seen previously. And we have here never seen oh, how, we have never seen that. So we give it like 0%. All these percentiles, I don't have to say it, but I will anyway say that, have obviously to add up to 100%. And we'll then take the word with the biggest percentile, how are, 12%. So let's snatch that, put it into the beginning. And here, how are, and then we have like the next word, how are you, data. And then we will give that, and take that word and snatch it and give it here. And this process, and this is important for us to understand, this process, while it learns, as I told you previously, with respect to looking to the data, understanding the patterns, it will then have a so-called probability distribution for every next word. And this every next word is called autoregressive. Okay, autoregressive. It will autoregressively um, create every new word. To be a little bit more specific, it actually creates every new token, but token is just a part of a word. You can also think of syllabus, syllabus, no, silbe, I don't know. Like you can just talk of a part of a word, but whatever. We will now in this talk think of words. And this is actually exactly what happens. So what happens with ChatGPT when it writes is actually, it will just understand, will have like a model, a framework, a multi-dimensional framework, which it will say, okay, now I started with these words. What is the most likely word coming next? What's the most likely token coming next? And this is actually what we are doing with ChatGPT in essence. And this is just happening further and further. And also maybe you have seen that now they come up other GPUs that are even faster. And we have probably seen that there are GPUs out that actually can create like 500 tokens. So let's say 270 words per second. So now the new GPUs are so fast that they can just create this in a split second, like really fast. Yeah, and this just gets faster and faster. Everything here is enabled by a database. These databases, they are like snatched openly, like they are like big zip files that you and I actually also can download, and then we can train it there. And these databases have one thing. Now we remember, okay, Gentrit, you said like, okay, we have like data and AI models or machine learning models or whatever, they understand the patterns. And with respect to the patterns, they don't know, okay, how is the probability of the next word, which is called autoregressive. Okay, so far so good. With respect to databases, we have to think of one thing, and that is that all these models, every one of them, actually is influenced by two things. One would be like the database, and one would be the engineering decisions. The database here has one specific caveat that I want to mention, and that is the unbalanced data that it has. So people ask me already, like, okay, why is prompt engineering so interesting? Because I also give like workshops in prompt engineering, and I then tell them like, okay, it's actually this pamphlet that's interesting for you. So here in the year 1784 in Berlin, there was like the question like, what is enlightenment? So here we can read that, what's enlightenment? And there was like a fellow, maybe somebody knows it, Immanuel Kant said like, wrote like a few pages on what enlightenment is. And this is also like how he participated in this form of enlightenment, where it happened like in Europe, and it was like a really big thing during that century, during that area. This specific pamphlet, though, you really have to search it. There is not the correct wording here. But on the other side, what we have a lot into what we will find in the internet is, for example, the First or the Second or the Fifth Amendment in the US, or here in Germany, like the Grundgesetz, paragraph 1. And that's like a mental framework that we have to think of. Okay, the data is spread differently, and with respect to a correct prompting, we can actually retrieve, or actually not retrieve, but make the probabilities higher that it will give us some more specific, more nuanced, more hidden data. And this is all like why it is important for us, after we have now learned for the past 15-20 years how to Google properly. We now have to learn how to interact with a model properly. After these mental framework, or after these frameworks of autoregressively having every next token, there were introduced some new frameworks which are even better. Now you could ask me like, what? Why new frameworks? Like, didn't you just tell us that every new word will then be autoregressively having like created, given like a probability distribution? That's just what I said, right? But I lied there a little bit. It has a few problems, the previous framework that I just told you, our architecture actually. It has a few problems. And one of them is, wait, I can just show you. One of them is this one here, 0. It will not create anything new. It will, if you think with respect to this, then it will just create always the same words, always the same pair of words. Or another problem is that this framework here will actually always look into the last, or the last 2 or the last 3 words. And if you were with me and looking into the slides properly, then you would also see actually the number 1948 down here. So this mental image that we had with autoregressively trying to generate every new word given the probability distribution is a thing that was not developed in 1948, but that was first cited that somebody else had developed it. So it was just like a citation, like as we have seen in this paper that was actually developed. So it's actually even before probably 1948, but I don't know where it is. During the 90s, we had like these 3 architectures, and we are now really like with big shoes, or with big feet, going into the direction of understanding the architecture, the transformer network that we are actually here to like understand. We're making really big steps forward. Now we have had 1948. This was a thing that I learned in the beginning of my master's. RNNs, LSTMs, GRUs. These are also frameworks or architectures that I also learned during my master's, specifically the first 2. Like there were actually state-of-the-art SOTA while I was trying to understand language models even better. These ones here, they actually had like an idea of going further back to understand the words, and try to not understand specific words, but actually more like the meaning behind sentences. So they were actually really good and actually working also really well. But then 2021, something dropped, and that was like ChatGPT 3.5, and everybody was just like amazed, and everybody was shocked at the same time. So now in the last 15 minutes, what I will do, I will explain to you where this transformer architecture actually came from and how it actually works on an intuitive level, as I already said. I will do that like every teacher would do that probably. I would like to do that with an example. The example starts with this stone. For somebody who doesn't know what this stone is, this is the so-called Rosetta Stone. Here in the upper part, we have Egypt, like Egyptian hieroglyphs. Here we have like a language called Domic. And here down there we have Greek, Old Greek. And this table made it possible for us to actually, from one nation, from one civilization, to understand the other civilization. If you think of that, we have here in Egyptian, no, here's Egyptian, sorry, here in Greek, we have like one sentence. And we, as we are Greek now in this scenario, we know exactly the specific words and the specific structure of our sentence, and we know when there is a point. On the other side, let's say we don't understand Egyptian, but we see, okay, this word actually appears here and appears here and appears here, and so on and so on. So we see, while doing this for days and weeks, we can slowly but steadily decipher a written text in Egypt as a reference using the Rosetta Stone. And the idea of connecting one language with another language, or connecting one word with another word, that actually brings us to the problem of alignment. If we now go into translation, we see two sentences. Japan shaken by two new quakes, and the same sentence also in French. We see here that we have a one-to-one alignment. Every one word in English has a specific translation in French. That's perfect. We are done. Yeah, right. We will say like, okay, now actually we just need the Oxford Dictionary or any other dictionary, whatever, for that sense, and then say like, okay, now we will try to exactly say one word to another. But probably for everybody who try to learn a second language, you will see that speaking in language, moving from one language to another is not that easy. It's not a specific one-to-one alignment, because there are also like these cases where we have one word in one language representing three different words in the other language. We have for you here implemented, which are three words. The matrix that is underlying looks like this. Or we have this one here, many to one alignment, where many words in one language, the source language, are one word in the target language. The matrix looks like this. Or even like the best out of both worlds would be this one here, many to many alignment. And this is the phrase alignment with respect to the matrix. Okay, so this matrix here, motivated by the idea of the Rosetta Stone. Obviously, I don't think that these people actually were thinking of the Rosetta Stone, but there's actually a really nice alignment. Was then used as a motivation to exactly publish this paper. This paper, attention is all you need, is a paper from all of them, like Google people, except from this guy. This one was from Toronto, University of Toronto. They introduced the so-called transformer architecture. They introduced this architecture, and they actually gave us the possibility to now have this whole AI revolution. So now we have here the Google people. They have created this one here. And then after creating this, maybe everybody who works in academia actually understands already like what happens next is some smart people will write something, some other let's say equally smart people, or people that are even able to understand the paper, will then peer review it. And then after they have peer reviewed it, it will then be put into the archive and will say like, okay, we have done enough. So that happens in 2017. What then happens is some other player snatched the paper. This other player was here, and that would be like OpenAI. OpenAI said, oh, hey, Google has done something really amazing. Let's take that and use that in some of our models. And they have already like seen really good results with their AlphaGo, which beat like the grandmaster in Go, and it was like amazing. And they have then also like seen reinforcement learning with human feedback. They have had really amazing track record, and then also like they have now seen the new architecture, and they were like, okay, let's use that because this has a lot of potential. So Google was actually the brain, as it already says, like Google brain. Actually, it's really funny to think of that. Google was the brain. OpenAI on the other side was the hand, was the person that actually the organization that took the information and actually did something by this. There were the engineers who did something with that and actually created like ChatGPT, GPT-1, GPT-2, GPT-3, and so on and so on and so on and so on. But OpenAI didn't have the funds to do so because engineers, they cost a lot, and also the training costs ridiculously, like it's so much. For example, ChatGPT 4, just to give you like a number, I hope I'm citing it correctly because they are not, I think they are not open with these numbers, but I think I saw somewhere like a number of 58 million USD. So it costs so much to just train these models. So we have here Google, who published this paper, which gave us the architecture that enables everything. We have here OpenAI, who then snatches the information and does something out of this. And we have here a third party, and that is Microsoft, who is actually just the really big like bundle of money that just gave them the money and said, okay, guys, do something great. But when you do something, we want a part of it. We want the model. And this is actually how also Bing was started, because Bing is just a so-called snapshot of GPT 3.5 for Omni and so on and so on. Okay. Now we have understood something. We have understood the participation of 3 companies. A fourth one is coming. I think for people who are in this field will already know exactly which fourth company is coming. But let's again like go into the architecture just for us for a last time to just understand it with respect to language. So we see here, Elira has bought a new book. She can hardly wait to read it. Okay? These are like 2 sentences. And previously, with all the other architecture that we have seen, where we were trying to connect the previous words with the current word, we try to have all the words like combining in one specific vector representation didn't also work really well. But now we're able to combine multiple words given this alignment phrasing matrix that we have seen with other words in the language in the sentence. So we see here, Elira, there is a high probability connection with she, and the book is a high probability connection with it. And this is happening in exactly these specific points of the whole architecture, the so-called attention heads. And this actually is the revolutionary idea, because everything else, so everything up there, we knew that. Like we know feed-forward networks, we know edge, we know normalization, we know skip, we know everything. But attention is the new thing that actually made everything possible. And it made even more possible for things for things that actually were not even, I will say, meant to be, or were not really like understanding that it's even possible. Because what I wanted to say is during 2022, end of 2022, 2023 beginning, there was one word that really were all over like the field that I was like the NLP field that I was working in, and this word is called emerging abilities. What the scientists have seen was that with bigger models, some new emerging abilities came up that they were not even able to understand where it came. So, for example, here, with a model complexity, so x-axis complexity, y is accuracy in this case, and in this case, like exact match, and so on and so on. Here, we see like with model complexity as another word for model size. So with bigger models, so let's say a model with 1 and 18 zeros, we say here weights, so many weights, was with respect to the accuracy on modular arithmetic really bad. But then at some point, just adding a few more zeros behind, suddenly the accuracy jumped from 0 to over 30. And this is like amazing. This is like amazing, where we were not able to understand why this is happening, but just go with it. Just have really clean data, have good data, have a really big GPU or GPUs actually, because you need a lot, and then just train it and let's see where it goes. And this was actually also like the idea during 2022, 2023, that people were just moving along. And also like other things are happening here with Persian Q&A. At some point it was random, where the matches were random, and at some point actually it could see connections with respect to question and answers. And that's like amazing, and we were not expecting that. Now, this slide, I have 4 more minutes. This slide will actually introduce or will actually motivate the last player in our whole understanding of where did everything come from, architectures and so on and so on. This slide has a really interesting, I would say, area. And this really interesting area is this area here, okay, where there are no models. So we see before 2020, in the middle of 2020, before GPT-3, there were no models that had actually a number of parameters, complexity, we remember, of over 10 billion, yeah, but even like here 1 billion before that, and so on and so on. So we see that there were actually no models that actually had this size, that actually were able to be created in the first place, until something happened, and that was NVIDIA. So we have here Google Brain created the architecture. OpenAI took it, engineering. Microsoft gave the money and also wanted a snapshot. And the fourth player here, down there, was NVIDIA. And NVIDIA, probably you have seen that. I live in Germany, so we have seen like in my fields, I've seen that NVIDIA's stock market is even bigger than the whole GPT of Germany. So this was really shocking, but also funny at the same time. And NVIDIA has done something, and that's amazing. And that would be that the new way of creating GPUs actually made it possible to create bigger and faster and faster and faster models. And this is actually where we are right now. So we see here in 2020, there were so many different models that they just had this ridiculous number of parameters. And this, it has enabled us right now to be able to create so many big models. And that was a cooperation of 4 American companies. Yeah, I was just thinking all of them are American, US, sorry. Yeah, what's special about ChatGPT? That's the last slides. Then I'm happy for questions from your side. And that is, if you have to boil it down, what's special for ChatGPT are 3 things, or what's special actually for all these new large language models are 3 things. First would be like the scale and the speed. The second, that's something that I've already talked about, so I will not go into that anymore. The second one would be like the creativity, and the third will be like steering or control. Let's go into creativity. What is actually creativity, or where does it come from? Creativity with respect to you and me, like for people, I guess now a model is not transcribing this. Let's say we're just human. It's easier to understand than it's not easier, sorry, it's more difficult to understand than the creativity with respect to a model. Because as you can only call something not creative or creative with respect to models if it's non-deterministic. I would say go with this. Obviously, it's a philosophical question. So creative, it would already be like when it can create the words or the sentences. How are you doing? I'm fine, thanks. Or how are you doing? I'm fine, I guess. So these two probabilities, or these two probability distributions that actually enable this, already are somewhat creative. And there is something called temperature, which actually lets us regulate the creativity of these models. So when we have a really, really small temperature, then we do exactly what we have seen with this autoregressive generation of the next token, of the next word. And that would be, we have a really small window of possibilities. We only take the probability, the word with the highest probability. But when we have a really high creativity, we open this window higher, so to be able to create to also generate new tokens. That would be creativity. How do we control them though, and how do we like tell them what to do actually, so that they actually also abide us? Another phrasing of that would be, how are we giving a ChatGPT some values from our side? How are we doing that? And the value giving, or the steering, the controlling, however you want to say that, actually happens by using reinforcement learning with human feedback. That's something, maybe remember, that's something that OpenAI already was really good when they created AlphaGo. So they had already like some experience with that, and they just combined this one framework with this new framework that is like the architecture that was introduced by Google. What happens here, to sum it up in a few sentences, would be ChatGPT is creating 4 different answers to one question, and then there's a so-called laborer who gives like an order. I like this question, I will like this answer better than this answer, better than this answer, better than this answer. And this, however, if you do this not 1 or 100 times, but thousands of times, done by thousands of people, then at some point you have like a model which actually understands which answers are better than some. And these are actually like the way of giving them some value. So what we have seen in the last slides were, we have understood an intuition of the connection of the different words with respect to a paragraph or multiple paragraphs. So very important for our prompts, because I promised like you will understand something with respect to your prompts, your prompting. You will now hopefully think that when you start with a specific word, you will then also, when you have to refer to the same word again, then you will you will use the exactly specifically same word down there. You will not do some ambiguation where you are saying like, here I use this word, then I use a similar word down there. No, you have to think a little bit more like a computer, where you actually want to have the probabilities of the connection of these different words higher, because the higher the probabilities of a specific word that you are giving, desto better it gives you the probability to also give you the answer that you are actually yielding or want. We have seen that. Then we have seen with respect to the architecture, which players actually came and how they are cooperated to actually give us this whole AI revolution. And in the end, we also have downplayed like what is so special. If we really have to pinpoint it, what is so special about all of these language models? That's everything from my side. I have to say thank you for your attention, and that's like a picture of mine. And if you want, in LinkedIn, I'm fairly active. Thank you very much, and now I'm available for questions.
Thank you very much, Gentrit, for your very illuminating and fascinating presentation, which, well, I'm not from there, but I'm very interested, and I understood mostly all. Gentrit, we have some questions, and I would love to invite everybody to shoot out your questions. Because this is a wonderful possibility to hear an expert talking and a philosopher as well. I'm fascinated by that, I have to say. Good. Let's start with the question of Lam. Lam, I will up. It's there. Hi. I would like to work on a personal project with LLMs to enrich my portfolio and facilitate my job search. I'm an ML engineer. So far, financially, the best solution to use GPUs is to use Google Colab. Is that enough to demonstrate some experience with LLMs? Sorry, I have to say, Lam is an alumni of ours.
Okay. Mm-hmm.
Go.
Okay, enrich my portfolio. So you want to do like you want to show some projects that you have done, and your pain point is you are not sure if Google Colab is already like enough to show that you have actually expertise when you create some models. I would say you can actually do really well with the current models. So I would say just go with it. Just go with Google Colab. Because what there are like different frameworks what you can do. Okay, let me go a little bit more technical. I don't know exactly the audience, but data science, so I can be a little bit more technical. Okay, so what you can do is you can think of, with respect to different NLP tasks, what you want to do. So one would be you can either do fine tuning, or you can do a more specific sentiment analysis, which is a little bit more traditional, but still like really, really good. Or you can do some other forms of fine tuning, some other tasks that would be like, for example, LoRa. You can Google that, for example, LoRa, or using adapters. And all of these, everything that I've said so far, all of them don't use a lot of not they use obviously like a lot, but not so much that you as an individual cannot do that. So I would just say go for it. Search for yourself like a subtask. If you want, you can obviously like write me on LinkedIn or whatever, and then I can also like discuss it with you. But just like find a subtask where you feel like, okay, here I can invest some time into going with it. Important to understand here is you will never probably be able with on net, let's not say never, because sometimes maybe, but you will now not be able to obviously like train a whole model from scratch, because that's done like with millions of US dollar and a lot of power. But what you can do is use adapters where you actually just free up one layer in the end, and then you just train the last layer of the whole neural network. And that's actually something that you can do, and a lot of people have done that, and there are a lot of papers actually online. Yeah. How many questions do we have, by the way? How long should I stick with one question? Can you tell me?
Well, we have some questions. It's not too many yet, but I'm quite sure they will come. Now, I
Okay.
would love to send you one question, which is from Saskia. It's a longer question, so that's why I will well put this the different lines.
Sure.
Hi there. My question: what is your preferred way to achieve some metacognitive or self-reflective ability in LMMs? For example, I'm thinking of layered context where the outer one is memorizing and summarizing the exchanges from the internal layer, with the possibility to interrupt or reroute the inner exchange when it's stuck to dead end, like a never end loop in a coding task. It sounds it's like expert to expert, I guess. I don't know. So let's go.
Can I see the whole question at once, by the way? Is this possible for me?
Uh, no, it's not possible, unfortunately.
Okay, then let me
I'm
read it like by myself. What's your preferred way to achieve some metacognitive or self-reflect? Okay, next. For example, I'm thinking of layered context where the outer one is memorizing and summarizing the exchange from the inner layer. Okay. With possibility to interrupt or reroute the inner exchange when it's stuck in a dead end, like a never-ending loop in a
this will
coding
be
task.
I
Okay.
guess this will be a question answered in more than 3 words, right?
The thing is, I don't understand it fully. That's the problem. I think I
Oh,
need a little bit more
sorry.
context. But I will try to say what I understood by the question, and I will
Mm,
answer my question. If you have any
good luck.
questions, hit me up in LinkedIn. What I understood so far was like, okay, I have like a deep neural network, and I want different layers of the network to understand or learn different tasks. That's what I understood so far. And with respect to this thing, what you are just trying to do is you can, first thing, like most obvious thing would be like to freeze stuff. So that would be like actually even one step further, one step before. The most obvious thing would just like to learn it longer, to just learn the deep neural network even longer until you understand like this more reflective way that it has to answer. Obviously, you need really clean data for that, so that it will also be really specific on specific contexts. That was be the first solution. The second solution would be like to split them up and then freeze different layers. So what you can do is you can You have two, like you have this inner and outer, you said, the inner and outer layer, and you can then give it like a task where you have only like the inner and the beginning layer for one specific task, and then you say like, okay, now I'm done with the task, now we'll freeze that, add some more layers on the right, and then also train it with respect to the previous and the new layers. That would be like a more like gluing them together way, but still like probably it works. Just try it out. I don't know, but some people are doing that. And the third thing, what I would tell you is probably um, to um, to do like two models, maybe not to understand like, okay, where you want to glue them synthetically together, but you have one specific model who does one specific task and another model who does another specific task. Then you are not having one model that is somehow influencing each other with respect to the weights, but you have two models. They are cooperating as some type of an agentic way of influencing one output and then influences the other model with respect to their output. So that would be like the third thing that I would let you know. I hope I understood your question. As I already said, just hit me up. Yeah.
Yes, it's always possible to well contact Gentrit by the contact details, either email or LinkedIn, with I very much well endorse. And right now we have from Saskia another a smaller question. Mm.
Mhm.
So
I
uh,
read that LLMs was trained on 100 and half.
LLAMA.
Genau.
So
Yeah, Llama. She means Llama.
yeah, Lama,
Uh,
Lama. Mm.
genau. So that Zuckerberg just a few days ago at for this it's a 4 billion US budget, really? 400 USD per hunt. That's a foreign budget, really. Yeah, that could vary. Like that is really normal numbers. I know it's amazing and it's so much money that they're investing and everything, but these are normal numbers. And this actually, these numbers are also the reason why, if you look into the internal numbers of, or actually not internal, but external numbers of OpenAI and other companies, that they're actually right now losing also money. Like I think OpenAI, if I'm not wrong, I read it somewhere, is losing like 120 million USD per year, because this model to train and to maintain, also like afterwards to maintain, because one question for a model is actually 4 times more expensive than a Google query, is so high that now also they have they have done these strategic solutions to actually create smaller models with the almost same abilities as the bigger models. Therefore, also we have now ChatGPT, no, GPT-4 Omni. That's actually the main reason why these models were now introduced to the public, because they are like smaller models, and because they are smaller models, they are faster, and not just because they are faster, they are smaller, but also because they are smaller, they're actually they have to invest less power and with respect to also money to actually make them run, and so on and so on and so on. So I think the field knows that that these models cost a lot, and also to maintain and train, but also the field is very interested in just seeing how far it goes, because the possibilities, and also as for example Mark Zuckerberg said, not Mark Zuckerberg, Sam Altman said, would I think every nation or everybody would invest millions and billions of dollars if theoretically a language model could solve cancer, for example. And this is what he said, and I think that this trajectory actually just continues. You're welcome.
Wonderful saying. Yeah, I just wanted to give some thank yous. The people are
So
very happy of your thing, what you
thanks.
said. And if I may say, you brought a very interesting word inside. It's investion. Okay,
Mm,
so the people are investing billions of dollars. The humankind is investing very much money
mm,
inside of all those language models into artificial intelligence, because this is the future, and this is the future which can give good. to
Mhm.
humankind. So we from data scientists are very, very into invest in the investor into yourself to invest with your time into learning all that. So get in contact with us, data scientist. We are a learning institution existing since 2017. We can give you certifications from the Sorbonne University. At the end, that's a nice investment, but you will invest in yourself and you will invest for, well, the good of humankind, if I may phrase it like this, with all of our trainings. I just wanted to tell you on this. So we have different webinars. Thank you again, Gentrit. It was really enlightening, and I'm not the only one who said this. Um, the if I may say, just there's one more question, and I
Sure.
can't leave questions away. So
Sure.
let's go. If you are okay with this, Gentrit,
Of course.
it's from Saskia. Finally, what's your take on neuromorphic chips, where Europe has very interesting project for once? What is that?
Okay. Neuromorphic chips. I don't wanna. I don't wanna pretend like I know what this is. Processors and neuromorphic computers have the following characteristic: collaborated process and memory. Ah, the brain-inspired neuromorphic computer chips process and store data together at each individual neuron instead of having separate areas for each. Nice, nice. Yeah, sounds good. Don't have anything to say. Sounds good. Yeah.
But my deepest compliments that you don't even try to look like you know everything, that you
No.
are strong enough to say I don't know. That's
Yeah.
wonderful, but it's a very interesting topic. So
Yeah, for sure. For sure. Yeah.
uh,
Sounds good.
so I'm very happy that you were here and you held this
Thank you.
beautiful webinar, Gentrit. If you allow me to say that we have many webinars, we are actually organizing them regularly. The next one is on the 6th of September with Tian Kai Feng with the topic engineering your personal brand. You're very invited to Gentrit, you too, huh? To come over and listen and learn. You always
Thanks.
learn. And on the 13th of September, there's Tobias Oberrauch from the Federal Association for Artificial Intelligence, KI Bundesverband in German, it's called.
Nice.
So you're heartily invited. I will be very happy to see you all there. And again, thank you very much, Gentrit, for your very
Thank you.
enlightened and loved webinar.
Thank you very much.
Okay?
And everybody have a nice now weekend, and I will hopefully see you next time.
Yes. Thank you.
Bye bye.
Bye.